4.3 derivatives of inverse trig functions. These are the worked out answers. So I promised I wouldn't write them this way, and of course I did. These all mean arc, cosine, arc, sine. So just so we're all on the same page. So, and the derivative y prime equals negative 1 over arc cosine pairs up with arc sine. So it's just the square root 1 minus 1 over x squared, and then times the derivative of x to the negative first, which is negative 1 over x squared. We do all this funky simplifying from here, just so you're on the same page. We get a positive here, get 1 over x squared. We change this inside to x squared over x squared minus 1 over x squared. This pops out as x, so this is going to cancel with just that. And if you recognize it, we have to say absolute value because that was going to be x squared. But not a big deal. You could stop here, that would be fine. Same idea, y prime equals 1 over square root of 1 minus t squared times negative 1 over 1 minus 2t plus t squared, negative 1 over 1 minus 1 negative, so it would be 2t minus t squared. Very careful on all the algebra. I believe this is straight off of a test or very close to a test. So y prime equals, leave it, 1/2 1 minus s squared to the negative 1/2 times negative 2s, cancel, plus square root of 1 minus s squared plus cosine negative 1 over square root of 1 minus s squared. This is on the bottom, so we got a common denominator. We're going to multiply this by that. Now we have negative s squared. This is plus 1 minus s squared. Right? Minus 1 all over 1 minus s squared equals negative 2s squared square root 1 minus s squared. All right. This is arc sine on the bottom, so I would have brought it up top and said sine. Don't like the way it's drawn. Arc sine 2x to the negative first. Y prime equals negative arc sine of 2x to the negative second times 1 over square root of 1 minus that squared, 4x squared times 2. That's it. There's really nothing to simplify over here. Arc sine 2x squared, 1 minus 4x squared, negative 2. Hideous looking math. In the following particle, find the velocity at t. One over square root of 1 minus t over 16 times 1/4 times 1 over 2 square root of t. Done, because they don't want the nice clean formula, they just want. What happens when I put in 4? 1 over square root of 1 minus 1/4 times 1 over 8 times 2. Equals 1 over 16 square root of 3 over 2 equals root 3 over 24, if I'm not mistaken. V of t equals 1 plus 1 plus t to the 4th times 2t. V of 1 equals 1 over 2 times 2 equals 1. Y prime equals 1 over absolute value of 5x, 25 x squared minus 1 times 5 equals 1 over absolute value of x, 25 x squared minus 1. All right, let's make this 4 over 4. These twos are going to cancel. My prime equals square root of 4 is going to flip up. Negative 2 over absolute value of x, square root of squared minus 1. My bad. 4. That's a 4, not a 1. Alrighty, onwards. My prime equals 1 over negative 1 over 1 plus t times 1 over 2 root t. That's really it. I mean, I could probably come up with some weird simplification, but there's really no reason to. 2 root t times 1 plus t. And y prime equals derivative 1/2 squared minus 1 to the negative 1/2 times 2s minus 1 over absolute value of s of s squared minus 1 equals guess I can multiply this by s squared over s, and I have a common denominator. I'll slap it inside the absolute value because I don't know what the heck's going on. So we have s squared minus 1. And we really have s times the absolute value of s minus 1. That's so weird. Over, I guess I'll just consider that absolute value of s. Yeah, really should multiply by absolute value over absolute value. S squared minus 1. Interesting. Y prime 1 over 1 plus x squared minus 1 times 1 over 2 root x squared minus 1 times 2x plus minus 1 over absolute value of x. X is greater than 1, so I get rid of this thing. Absolute value, x squared minus 1 equals 2 cancel. One of the x's cancel. X is still there. 1 over x, 1 over x, 0. As long as x is greater than 1. Cool math. And y prime equals 1 over 1 plus x squared negative minus 1 over 1 plus x squared. I forgot my chain rule. Times negative 1 over x squared. Yeah. Equals 1. I'm going to roll this x squared through the bottom. X squared plus 1 minus 1 over 1 plus x squared also equals 0. As long as x doesn't equal 0. Because you can't put it in as 0. Wow, those are right off of the quiz. Hope people do those. Find from front between 10 lines, so I need a point. So 2 comma, plug it in arctangent in my calculator, I get 1.107. That's hideous. I could just say arctangent of 2, but yeah, we can do better than that. Y prime equals 1 over 1 plus x squared. Y prime of 2 equals 1/5. Tangent line. Y equals 1/5 x minus 2 plus 1.107. Plug in 3, we get 3 comma 0.848 straight out of the calculator. And then we go with y prime equals 1 over square root 1 minus x squared over 16 times 1/4 y prime of 3 equals 4 times 9. 16 minus 9 is 7/16. Root 7 over 4 by equals root 7 or 7 equals 0.378. Whatever you want to do. Tangent line, y equals, I'm going to leave it as root 7 over 7. X minus 3 plus 0.848. Find equation line, tangent to the graph, y equals tangent x point. Sure. dy dx equals secant squared x. dy dx cosine of pi is -1 over -1. No, squared is 1. No, it's not pi over 2, it's pi over 4. It's not pi, it's pi over 4. Cosine of pi over 4 is root 2 over 2. Squared is 2 over 4 is 1/2. Flips up, becomes 2. So tangent line, y equals 2x minus pi plus 1. dy dx equals 1 over 1 plus x squared. dy dx, x equals 1, 1/2. Ooh, look at that. They're not reciprocal, but hey, they could be. No, they're not. Anyway, tangent line, they're not, what do you call it? They're reciprocals, they're not inverses. Y equals 1/2 x minus pi. I was looking up. X minus 1 plus pi over 4. Interesting. That's about all I have to say about that. Okay. Let f of x equal yada yada. Show that f has a differentiable inverse. Okay. F prime of x equals negative sine of x plus 3. Since sine of x varies -1 to 1, okay, it's plus 3, f of prime of x cannot equal 0. Therefore, f has a differentiable inverse. If you think I just made that up, you're probably right. I'm not sure where I got that from, but let me just stop and think for a second. Let me find the differentiable inverse. I would go y equals and all that, but it's generally going to be 1 over f prime. So yeah. All right, let's see what happens. F of 0 equals 1. Therefore, f, the inverse of 1 equals 0. F prime of 0 equals 3. So the inverse would just flip them around. X equals cosine of y plus 3y. We would have to do this implicitly. 1 equals negative sine of y dy dx plus 3 dy dx. So the derivative of the inverse equals 1 over 3 minus sine of y. So let's see if I got them all. F of 0 is 1. F prime of 0 is 3. F negative inverse of 1 is 0. Wow, I'm on a freaking roll. I'm very impressed with myself. And then f to the negative first of 1 prime. That's really horrible. I do this. Yeah, I can't do that. I don't have it in me. GDX is, well, we don't put in 1. Yes, we do. Yeah, it's the y value. So if x is 1, y is 0. Sine of 0, 0 is 1/3. More on that in 2 lessons, not the next lesson, but the lesson after that. Wow, good stuff. Good luck and happy mathing.